Good morning, fourth graders. This is Mr. Peters. I'm going to go through the Unit 6 post-test with you guys. I'm going to do some of the problems on here and then do a separate video to show some of the others that need a little bit more drawing on them. And so you'll recognize that the post-test, once again, is very similar to the pre-test that you guys took while we're all still at school. And so as I'm going through this, I would encourage you to pause the video before I do the work. That way you can see the work and possibly try to do it on your own. You can do it in a notebook, dry erase board if you have one. But yeah, just give yourself a chance to work through some of the problems to really kind of see how you feel you're doing throughout the unit as well. All right, so on this first one, it says Shin used a doubling and halving strategy to solve 25 times 68. Fill in the blanks and the arrays and the equations to represent her work. So first thing we want to look at is that she is using the doubling and halving strategy. So one of the numbers is going to get doubled, the other one is going to get cut in half. So if we look, we start with 25 times 68, and then we move over to 50 times something. So the number that got doubled is the 25. So we are doubling this. So that means that 68 has to get cut in half. So half of 60 is 30. Half of 8 is 4. So this part should be 34. Now if we continue on, we double our 50 again, we get to 100. And then we cut our 34 in half again. So half of 30 is 15. Half of 4 is 2. 15 plus 2 is 17. Okay, so then we're taking our information from up here. We're going to transfer it down here. So we went from 25 times 68 to our new problem of 50 times 34. And then we went over and we did it again, and we're now over to 100 times 17. And so once you realize with this problem, the doubling and halving makes it quite an easier problem. And so now we just have to do 17 times 100. 17 100s would be 1700 or 1700. Okay, so once again, the big thing with that one is looking at the doubling and halving strategy there. Next, we're doing true or false. So we need to just check the problems and see which ones are correct and which ones they possibly made a mistake somewhere along the way. And once again, they're going to be using some of our strategies, doubling and halving, splitting, different things like that. So if you look at the first one, we have 29 times 18 equals 30 times 18 minus 1 times 18. Okay, so they went from our 29 and they moved it up to 30. That 1 gets multiplied by 18. So they had to remove that. So this one is true. Then down here we have, or over here we have B, we have 32 times 17 equals 16 times 17. So if we look at this, what they did here is our 32 got cut in half and became 16, and our 17 got doubled and became 34. So they did the doubling and halving. So that one is true also. And then going down to C, 34 times 62 equals 30 times 60 plus 4 times 2. Now with this one, if you drew it out and did a array or area model here, and we had our 62 and our 34, they did the 30 times the 60, they did the 4 times the 2. If you notice, there's 2 squares here that are empty. So this problem wouldn't have worked. They did not complete the multiplication problem. So that would be false. They forgot to do their cross multiplying on that. Is that? All right. Then on D, 63 divided by 6 equals 10 with a remainder of 4. So if we reversed our problem, we did 6 times 10, we would get up to 60, but there would be 3 left over, not 4. And so this one is false as well. Going down to these bottom ones. On these ones, I'm going to save these few for our video, the other video that I'm going to take. So feel free to work on these, but I will do these on a separate one where I have a bigger whiteboard for us to show the work on. Then going over here, sorry about that. I'll make this one a little bigger. All right, once again, we have these equations up here. And so this time, instead of doing true or false, we need to plug parts in to make them true. And so once again, Bridges was nice, though, to us that they set them up in a certain way that we could see how the numbers are related. So we have 38 times 32 equals blank times 16. So the 32 is connected to the 16. So if you pay attention to that, you notice that they simply cut the 32 in half. So with our strategy of what you do for multiplication problems, if you cut one in half, that means you have to double the other one. So double 38, double 30 is 60, double 8 is 16. 60 plus 16 would be 76. Then on our next problem over here, for B, we have 104 times 5 equals blank times 10. So once again, the connection is the 5 and the 10. 5 doubled is 10. So this time we have to cut the 104 in half. So half of 100 is 50. Half of 4 is 2. So that is 52. Now, here's one that's a little bit more of a challenge, but we can still do it. We first start with 99 times 87 equals blank times 87 minus 1 times 87. And one of the first things you should ask yourself is, how would I solve this problem? And if you look at that, well, the 99 is really close to the number 100. So if we moved up 1, that'd be 1 times 87, which they actually did over here. So if we put in 100, we do 100 times 87, and then get rid of the one set of 87. That would be the same as 99 times 87. So it is balanced out. They equal each other eventually. Now over here, we have 47 times 32 equals blank times 30 plus 47 times 2. So with this one, it's similar to one of them that they did on the front page, but on the front page it was a false problem. So when we look here, though, they have the 47 still. They split apart the 30 and the 2. So the 2 got multiplied by the 47, but the 30 hasn't yet. So that tells us that this one simply has to just be 47 because we're splitting the 32 into 30 and 2 and still multiplying both numbers by the 47. Same idea over here. We have 36 times 59. The 59 is staying the same, but they split the 36. So this is 30, this is 6. So once again, it's an opportunity to kind of work a little bit smarter, not harder. You don't have to solve the whole problem, but they want you to find out how you could solve it and break it apart. All right, on these problems here, I should be able to write these ones out. So with my class, one of the things I said, whenever you're using a ratio table, try to label it. When you put the labels on there, it makes it a little bit easier. So we're trying to do 288 divided by 9. So if we said that this was a team and this was players, you have one team had 9 players. Okay, so that's the ratio. So really what we're taking the 288 players and we need to find out how many teams it's going to take if we put 9 players on each team. Okay, so one team had 9. We could do a nice big friendly jump and go up to 10. All right, so that'd be 90. Okay, let's add another 10. Let's try doing, try doing 20. 20 times 9 would be 180. If I add another 9, or sorry, not another 10 teams to our group, 30 teams of 9 players each, we could make or have 270 players playing. So now we're getting pretty close. So here's where you want to see what's the difference between 270 and 288. And you'll notice that there's only 18. It's only 18 away. So that means if we're looking at 9, we only need to add 2 more teams to get that extra 18. Okay, now here's one of the tricky parts that some kids like to do. They like to try to add everything up here on the top. But we don't want to add everything up on the top. We are simply looking to see which total down here on the bottom gets us to that 288 over here. So when we go back and we look, we added the 270 plus 18 to get to that, to get to 288. Now when we go back, we have our 288 players, and that took 30 teams here, plus those 2 teams, which will equal 30 plus 2 is 32 teams. Okay. So once again, when we go back, if we label it teams and players, sometimes that helps with trying to figure out what it is that we're trying to do here. Okay. All right, let me just erase these marks down here to give us a little bit more room. All right, finish the array to find 976 divided by 8. Okay, and they already have 8 times 50 is 400. So one of the things that you want to look at right away, first of all, if we're doing division and using an array, when we do multiplication, do this side times this side equals that side, or equals the center, I'm sorry. Okay, but with division, it's the middle divided by a side equals the other side. So we are given our one side. The one side over here is 8. That's always going to stay the same because that's right here in our problem. Okay. Now we need to figure out how much is in our center. We need to get it up to 976. So if we're at 400, right away we can realize, well, if I'm at 400 and I need to get to 976, I could double that. So when we double that, we put another 400 here. And this was 8 times 50 is 400. So we're going to do 8 times 50 right here is 400. So now we have 400 plus 400, which is 800. And we need to build up to 976. So one of the things we can do is, if we wanted, we're multiplying by 8, we could make it a little bit smaller. We don't want to go too big. If we added 10 to this side, 8 times 10 is 80. So now we have 400 plus 400 is 800, 880. So if we're thinking, we might be able to add another 10. That top side, let's check. 10 times 8 is another 80. 80 plus 80 is 160. 400 is 800. When you put that together, we're at 960 so far. So we're at 960, and our target number is 976. That means we're only 16 away. So we need to do 8 times something to equal 16, which all you great 4th grade minds know that it's 8 times 2 is 16. So now we want to check our center. We have 400 plus 400 is 800. 80 and 80 is 160. So that's 960 so far. Plus our 16 is 976. So 976 in the center divided by the 8 equals this whole side. And so on this side, we have, let me give it that mark there. 50 plus 50 is 100. Plus 10 is 120. Plus the 2 is 122. All right. Once again, I'm going to save problem number 7. I'm going to save this one for another video for you, where I can just show it a little bit easier on a whiteboard, on a bigger one. Okay. But on this problem, it says the Boys and Girls Club in our town is collecting bottled water to donate to the Red Cross. The goal is to collect 1,000 bottles. So far, they have collected 29 cases of 24 bottles and 15 half cases of 12 bottles. How many more bottles of water do they need to collect to meet their goal of 1,000? Okay, we'll get to that one. Next one. All right. are 4 friends going to a concert. They pay a group rate of 176. How much does each friend pay? Show your work. So total amount paid was 176. So we're looking at our equation. Oh, wow. That was really sloppy with the computer. $176 divided by the 4 friends equals blank. Now, one of the things that I would do for myself is I would rearrange this into a multiplication problem. And I know some of you would do that too. And so you would ask yourself, 4 times what equals 176? And so since we can solve this problem any way that we want, for me, I'm going to build our array up to 176. So we have our 4 friends. I'm going to say, well, I know I'm trying to think of 4 times what gets me close to it. If I do 4 times 40, because I know 4 times 4 is 16, so 4 times 40 is going to be 160. That got me really close right away. And now I only need 16 more to get up to the next number. And once again, 4 times 4 is 16. 160 plus the 16 gets us up to our target of 176. So our 4 friends each has to pay $44. Okay, and so using our multiplication, that kind of helped me set up my problem here. And if you wanted to check it, you could end up drawing your own array and lay it out and ask yourself, 4 times 40, what does that equal? 4 times 40, yep, that's 160. 4 times 4, that's 16. Yep, that got us to our total. We can double check it that way. Now this one's a little bit different. After the concert, 4 friends ordered a large pitcher of soda. How much does each of the 4 friends need to pay? So now we're doing a $7 pitcher of soda, and we're dividing it between the 4 friends. Now, with this, once again, we're doing money here. So we're dividing between our 4 friends. And so what we could do is, well, we could say, well, there's 4 friends. Each friend needs to pay at least $1. Okay? Because 4 friends each paying $1 to get us to $4. That would leave $3 left over for them to each pay. And this is where some of you guys would like to do the loops and groups for an old strategy that you've done. And that would work out just fine. You'd say $1, $1, $1, $1 for each of them. Now, if we notice, right away, we know it has to be less than $2 because if each friend paid $2 and we have 4 friends, it's going to be $8. So right away, we know it has to be less than 2, but more than 1. So we can put our decimal in there. Now, what we can look at is we could ask ourselves, okay, what if each friend paid an extra 50 cents? All right, so we have our $1 for each person. Oops, sorry. And then if we put 50 cents for each one. So 50 cents plus 50 cents plus 50 cents plus 50 cents, that equals $2 more. So originally we did $1, $2, $3, $4 plus 2 more. We have $6 we've given out. So we have $1 left that we need to split up by 4. And once again, we should all know that $1 divided by 4, just like quarters, would be 25 cents. So we put on another 25 cents for each of them. And so the total might be easiest just to look here at the end is $1, and then we had 50 and 25. So that's 50 cents plus 25 cents, that's 75 cents, so $1.75. Okay. Now I'm going to show one other way to solve this problem. If it works for you, great. If it doesn't work for you, you can just leave it and that's all right. So one of the things I've showed some of my kiddos this year is that division is really just fractions. So 7 divided by 4 is really 7 fourths. And if we think about money with fourths are supposed to be quarters, right? So 7 fourths is 7 quarters. And if we took the money of quarters, 7 quarters, well, 4 quarters is $1. 3 more quarters would be 75 cents. So it would be the same as $1.75. 7/4 would equal $1.75 because that's 1 and 3/4. Now, since we did money though, what do we change our remainder into? That leftover stuff that wasn't a whole dollar, we changed it into a decimal. And why do we do that was money can be a decimal. All right. Now, these problems, especially this top one here, is a really great chance of working smarter, not harder. If we pause and look and see what we have to do. The area of a path is 7,049 square feet. One of the dimensions is 7 feet. What is the length of the other dimension? So first of all, it's a path. Typically, one side is a lot longer of a path than the other, if you think about like a sidewalk. So if we drew a picture here to give ourselves a kind of a head start, we know that one side is 7, and this whole inside is 7,049. I don't know about you, but that kind of makes me pretty excited because when I look at it, I see 7,000 and then I see 49. I know there's a connection. So I could simply tell myself, well, part of the side is going to be at least 1,000 because 7 times 1,000 is 7,000. By the way, really what we're doing here is we did 7,049 divided by 7. Okay. And once again, we can rearrange it to multiplication problem here too to make it a little bit easier. And so now on our next part, we're trying to figure out what goes up to 49 to get this 49 here. Well, 7 times something equals 49. That's 7 times 7 equals 49. So when we go back to our story problem, the area is 7,049. The one side or one dimension is 7. The other dimension or length is 1,007. Once again, that's feet, so we want to make sure we label it. So 1,007 feet long. Okay, you could use smaller numbers to build it up, but when you think about 7 times something to get up to 7,000, it's going to have to be a big number right away. So doing by tens and things like that, or even hundreds, would be a little bit slow. Now here, the perimeter of a rectangle is 734 centimeters. One of the dimensions is 116 centimeters. What is the length of the other dimension? Use labeled sketches and equations to model your work. Okay, so if we label our drawing here, we have a rectangle. Remember, perimeter is all the way around. So one dimension is 116. So if we know this side is 116, remember for perimeter, we can do equals length times 2 plus width times 2. Or a lot of kids just like to do length plus width plus length plus width. We add up all the sides. So if this side is 116 and it's a rectangle, we automatically know that this side over here has to be 116. So far, we've got, for our equation here, we have 116 and 116. So 116 plus 116, well, 100 plus 100 is 200, and 16 plus 16 is 32. So far, we've used 232. But we still need to figure out the other 734 centimeters. So we have to figure out what's left over from it. So if we take our 734 and we tell ourselves, well, we already put out the 116 and 116, what's left over? So 4 minus 2 is 2. 3 minus 3 is 0. 7 minus 2 is 5. Sorry, that's an ugly 5 there. Let me fix that. Right now on the screen doesn't always work out so pretty. 502. So the answer, a lot of people would want to say is, oh, it's 502. But we have two sides we need to share equally. So split our 500 into 2. So 500 split in half is 250. And then we had that 2 right here. 2 split in half is obviously 1. So it is 251 for right here. 251 for right here. Now if we put our stuff in the equation, we have 251 plus 116 plus 251 plus 116. Okay. So we go back. All of those add up to our 734. So we are done with our work. But our answer, what is the length of the other dimension? We knew the 116. The other dimension is 251, and that is centimeters. 251 centimeters. All right, and the last one here. All right, once again, with this page, I'm going to do these problems on a different video for you that I'll upload at the same time. Let me zoom in though so you can see what work we're doing. So we're going to make a line plot here. So here's our story problem. Once again, you can pause this one to see kind of the stuff. Dylan is digging up worms in his backyard and measuring their length for a science project. This table shows the length of every worm he has found so far. So here's his table. There's the length. I know it's kind of hard for you to probably see that. Complete the line plot below to display the information shown in the chart. Be sure to finish labeling all the marks along the line plot before you plot your data. So we're going to want to make this part first, and then we'll put in our data. Okay. Now here, what is the difference in length between the shortest and longest worm? We'll be able to answer that question pretty easily once we fill out our data. And then Dylan's little brother laid all the worms that were 4.5 inches long end to end. How long did they measure? Once again, when we have 4.5, we'll be able to see quickly how many worms it is and just add them together. All right. Thank you guys for listening to this video. Once again, I'm going to make one more for you that you guys will get it on the same day to see some of the other problems. Keep up the good work.